In order to support abstraction in our programming language, we need to be able to bind symbols to values. And we do that with the define expression. So let's talk a little bit about how the mechanics of that work in the interpreter that you're going to build. So define binds a symbol to a value in the first frame of the current environment. And we just saw that frames are objects that behave like dictionaries, but they can chain because they have parents. And so when you look something up, you might find it in the parent frame. The define expression just gives a name and an expression. We evaluate the expression, then bind the name to its value in the current frame. So if I define x to be plus 1, 2, notice that we evaluate plus 1, 2. So we get 3, and x is then bound to the number 3. It's forgotten the expression that created 3. It really just knows that it's the value 3. Procedure definition is shorthand for define with a lambda expression. So when I say I'm going to define a new procedure which has a name and some formal parameters and a body, all I'm really saying is I'm going to define a new name that evaluates to a procedure with some formal parameters and a body. So these two expressions are completely equivalent in scheme, and that means they should be handled in the same way in the interpreter that we built. So when a define expression like this is encountered, it gets converted into something that looks like this, and then we apply our regular procedure for evaluating a lambda expression and then binding that procedure value to a name. Okay, so applying user-defined procedures is something we can do. We saw a demo of it in the very first video of this lecture. To apply a user-defined procedure, we create a new frame in which formal parameters are bound to argument values, whose parent is the environment of the procedure. And env here is an attribute of the procedure object that remembers the environment in which the procedure was originally defined. Okay, then we evaluate the body of the procedure in the environment that starts with this new frame. So, let's return to the demonstration that we started with at the very beginning of this lecture. This demo procedure returns a new list, taking in an old list and giving us back something with the same elements, but also the number 3 at the end. So let's look at the environments that are created. When I define this thing, then I've bound the name demo to some lambda procedure instance, which has its parent as the global frame. Then, when I call it, that involves creating a list 1, 2, which we can represent as nested pairs, creating a new frame in which formal parameters are bound to the argument value. So the formal parameter s is bound to the argument value, which is this list, and whose parent is g, also the parent of the lambda procedure that was just applied. Okay, now if we look through the body of this thing, so we're evaluating the body and we realize s is not null, so we have to call demo on the coulter of s, which means we introduce yet another frame where s is now bound to the coulter of s, which is the rest of s, everything except for the first element. Making another recursive call, we find that we're now binding s to whatever is the coulter of this s, which is just the empty list called nil. And when we evaluate the body of this procedure with s bound to the nil list, then we just return 3. And this one returns 2, 3, this one returns 1, 2, 3. But in this environment, we're not keeping track of return values. That happens elsewhere in the program. Now this idea that you can evaluate and apply recursively is really old. So here's the original definitions of apply and eval in the documentation for Lisp 1.5, which was the predecessor to scheme. So this is very old, but it has much of the structure that you see today, though in a different syntax. It kept track of things like car and coulter and cons. Those were built in. There was a check if something was atomic, that's just a number. There was also a built-in notion of equality. Other than that, there were just built-in notions of quotation and conditionals, and everything else you had to build from there, except for our famous lambda. So, as you can see, eval dispatches on the type of thing and calls apply, and apply calls eval. Cool.